I'm gonna be solving the chemistry quiz. So here in the first question it says a chemist dissolved 0.45 grams of acetic acid to make 1 liter of solution. So here in the first part they want the concentration. Concentration, the formula for it is C equals N over V. This is number of moles over volume. The concentration equals number of moles over volume. We don't have the number of moles, but we do have the volume. So the volume is equal to 1 liter. Anything over 1, N over 1 is equal to N, صح? So N over 1 which is just equal to N. So in this case, only in this case, because the N over 1 equals C. Now they give us what we need to find N. They give us the mass and the molar mass. The mass in this case is 45 grams. So the formula to find the number of moles from these two, N equals mass over molar mass. The M is 45 grams. So we'll write M equals 45, capital M or molar mass equals 60. Sometimes in exams they don't give you this. They want you to calculate and find it yourself. Like they give you a periodic table and you add up everything. So now N is equal to M over M, capital M, which is equal to 45 over 60. 45 over 60 equal to 0.75. So now we can replace it. Now we erase the N here and we replace it with what we just got. N equals 0.75. 0.75 over 1 equals C. So what does that mean? C is 0.75. Now the second part, I honestly had to watch a YouTube video about it, and it had something to do with the A level basically. So look, here they're giving us K and they want us to find H plus. So Ka is something called dissociation constant. So remember from before, from chapter 1, K is the equilibrium constant, which is equal to concentration of products. By the way, whenever you see these two, they just mean concentration of over concentration of reactants. So let's say you have product A and product B. It would be concentration of product A times, I'm just gonna write P for product B, and then RB, and it's always to the power of its coefficient. But here we have no coefficients, so it doesn't matter. So look what we do here. Usually, this is common sense. If you look at almost every formula by now, you should know this. We have H and we have, let's say, A. This is an acid. It's made up of H plus and then anion. صح? So we're using A as anion. And when it dissolves, it separates or dissociates into H plus plus A minus. So in this case, A is CH3COO. So now I'm gonna replace everything by what we have. So CH3 COOH dissolves and dissociates into H plus plus CH3COO minus. Now, I didn't fully explain why we needed the HA dissolved into whatever. So by using HA, we can tell that the equilibrium constant of an acid, Ka, equals to H plus times A minus over HA. Because again, remember, it's HA gives you H plus plus A minus. So it's the products over the reactants, which is exactly what's happening here. So now, here's where the tricky part comes in. Whenever the H and the A are 1-to-1 ratio, they're equal, صح? So that means we can say that H plus is equal to A minus. So that means we can replace this part with H plus because they're the exact same concentration in the end. We're not trying to find the compound itself, we're trying to find the concentration. It should be the same. So what does that mean? That means, what's H plus times H plus? It's like what's saying what's X times X? It's just X squared. So the concentration of H plus is the concentration of H plus squared over Ka. Squared over Ha gives you the acid equilibrium. So now you just substitute everything you have, or you can simplify it to get it in terms of H plus. So I'm just gonna erase all of it. So that means if you cross multiply, you get H plus squared equals to Ka times Ha, the acid. Ha is the acid, yeah? From now on, instead of writing Ha, I'm just gonna write acid so you guys don't get more confused. Times concentration of acid. Square root both sides. The 2 cancels out. This is what you want to do. They already give you Ka, which is good. And by the way, this formula is only used if the 2 reactants are at a 1-to-1 ratio, because they're equal then. So now, swap everything. So that means H plus should equal to radical 1.8 times 10 to the negative 5 times 0.75. You get the thing is, for some reason you get 0.36 like 0.368, something like that. So so I don't know why it's 0.03. Let's just check. Times 0.75. Yeah, I got 0.03674234461. So I don't know why we don't round it up to 0.037. That's basically how to do it. And I don't even remember taking this. I'm not 100% sure if it's coming. If you guys don't understand, you can ask me or ask a teacher, or you can look up a YouTube video on it. So here they're asking, when you titrate an acid with a base, what's the color change that occurs when methyl orange is used? So methyl orange, the only thing you need to remember, so I'll write here methyl, I'll make a table for you. So here you have acid and you have base. Here we'll write methyl orange. Methyl orange in an acid is red and in a base is yellow. When you titrate, you're adding little drops. So titration of an acid with a base, that means you have an acid in a beaker and you're adding little drops of a base one by one into the obviously not by hand, use a burette for it and you just open it so it can drop little drops, but over time the base is gonna be more than the acid, so it's gonna turn yellow. So here electrolysis is the opposite of electrolysis is kind of the opposite of the electrochemical. So the electrochemical, you're trying to change chemical energy into electric energy. So the electrolysis, you're doing the opposite. You're forcing electricity to turn into chemical energy. So usually for this is the it's usually the same. Yeah, it is the same, but it's mainly these. So if I missed anything, my bad, but they're not that important. So here's the thing. The thing is, in electrolysis, in electrochemical cells, you're trying to find the more stable one to get oxidized. But in electrolysis, you're trying to do the opposite. You're trying to make the cation gets reduced. So here, usually in electrolysis, you'd pick the one higher. That's because we're in electrochemical, you want to pick the one lower. You want to pick the more reactive one. So look here. Concentrated solution, that means I'll tell you why concentrated and diluted is important when we get to the second part. So we have a solution always, and I'll also write the one for the anions. So 4,2 minus, NO3 minus, OH minus, and then you have the halides, Br minus, Cl, Br, I, Cl minus, Br minus, I minus. So here the always kind of write a table. You have cations and you have the anions. The anions are gonna be the anions are gonna be the ones oxide, so they're at the anode, and the cations are gonna be reduced, so they're at the cathode. So the cations you have here are K plus and H plus. Why H plus? Because it's in water. So with the water dissolved, there's gonna be H plus ions. And the anions you have here are Br2. No, it doesn't make sense. Br minus and OH minus. Because again, it's dissolved in water, so you're gonna have H plus and OH minus. Find out from these two which ones are lower. So here the Br is lower, and here the H plus is lower. Whichever one is lower is the one the reaction is gonna happen to. So here the H plus is gonna get reduced, and the Br is gonna get oxidized. The equation for H plus being reduced is this. Plus E minus gives you H2 gas. So add it to here to balance. That's why they're asking for the product. Like, they're basically asking what compound are you gonna get at the end when this gets oxidized or whatever. So here, so the product here is H2, and for Br minus it's basically the same thing. It's just it's getting oxidized, except it's getting oxidized instead of reduced. Here's where the diluted becomes important. So here, when it's diluted, that means there's a lot of H plus and OH minus. So no matter what it is, the OH plus will always be oxidized if it's diluted. I'll give you an example. Here are Cl and O2 is the correct answer. So let's go back. Cation, I'll just write. So you have Na and H. Here you have Cl and OH. Now since it's diluted, that means there's a lot of water. That's when it's concentrated, that means the difference between the number of moles and the volume isn't that much. When it's diluted, it means it's a lot. There's a lot of water compared to the solution. So look here. What's always gonna be picked if it's diluted is OH minus. Even though if you go to the list, Cl is lower, صح? You're always gonna pick OH minus. And for this one, it's not the same for H plus. The only reason we picked H plus because it's lower. And now finally for the last one, it's again diluted. So obviously, because it's diluted, we're gonna pick OH minus. Here we have SO4 2 minus, and even if it wasn't diluted, it would also be OH minus, because look, it's at the top. And then the other two you have are H plus and Cu plus. Check here which one's lower. Cu plus. That's why it's the one is the correct answer here, because it's lower. For H plus it doesn't matter, but for OH minus it does when it's diluted. Find, since asked find OH minus This question's been repeated so many times, so I'm gonna solve it anyways. So you should know by now, concentration of H plus equals 10 to the negative pH. So that means concentration of H plus is 5.36. Keep it that way. Then you have Kw equals to H plus times OH minus. You should also know this. OH minus. It's something we took it a lot. And the reason is, so the equilibrium is the way this works is the reactant here is H2O, but the only thing you care about in this are aqueous and gases only. H2O is a liquid. So that's why it's over nothing. Because there is nothing for it to be over. خلاص. So H plus and OH minus, this is the formula for it. So that means OH minus equals to Kw over H plus. Kw is given, and you should also memorize both. It's given and you should memorize. It's just 10 to the negative 14 equals to 10 to the negative 14 over 10 to the negative 5.36, and then you get your answer. Student is asked to find the pH of a solution. In an experiment, he prepares aqueous solution of hydrochloric acid by dissolving 0.08 moles, 250 milliliters, volumetric flask. Again, this is a repeat. I solved it already in the periodic, but so I'm just gonna do it anyways. So here you have HCl. You have 0.08 moles of it. So I'm gonna write the full equation. HCl dissolves and gives you H plus Cl minus. You have 0.08 moles of HCl right now. They want the concentration of H plus. So look, concentration is like the first question. C equals N over V. C equals N over V. N is given as 0.08. And V is given as 250 milliliters. You always want it in liters though. So to make it liters, you divide by 1,000 over 1,000, which is equal to 0.25. So you just do 0.08 over 0.25, and that's what you get. So now we know that that's C, 0.32. 0.32. It's a 1-to-1 ratio. If 1 gives you 1, 0.32 gives you X. Cross multiply 0.32. It's the same. So it's the same concentration by now. Now they want the pH. Formula for pH is negative log 10 concentration of H plus. So just negative log 10, 0.32, and you get your answer. A student wants to find the concentration of hydrogen ions and hydroxide ions in a sample of 0.4 moles molarity strong acid H2A aqueous solution at 298 K. Now look, you have H2A gives you 2H plus A minus. Why 2H plus? Because there's a 2 here, you have to balance it. So now it's not a 1-to-1 ratio anymore, it's a 1-to-2 ratio. So 1 gives you 2. 0.4 now molarity gives you X. We don't know what it gives you. Cross multiply. X equals 2 times 0.4 which is equal to 0.8. That's why I wrote it here. See? Now down here is the same as it was 2 questions ago, yeah. So KW equals H plus times OH minus. So that means KW over H plus equals to OH minus, which is equal to, and KW is given again, 10 to the negative 14 over 0.8. That's what you get. Calculate the concentration of hydrogen ions in a 0.06 molarity aqueous solution of KOH. A lot of these questions are just repeat, they're really easy. So you can see already it's a 1-to-1 ratio. KOH gives you K plus OH minus, 1-to-1 ratio, so it's the same concentration. 0.06 equals to OH minus. KW equals to H plus times OH minus. Divide both sides by OH minus to get H plus alone over OH minus, which is equal to 10 to the negative 14 over 0.06. And that's it. Okay, oxidation number. Something you should memorize is that O is always equal to negative 2 unless, here I'm writing unless with F minus or peroxides. Peroxides is like an example, be like N2O2, H2O2, stuff like that. So when it's peroxide, it's plus 1, and to the F minus, it's positive 2. I'll explain why now fast. So I have to do OF2. And F, doesn't matter what it's with, it's always going to be minus 1. So we want to find X now. So we have 2 times negative 1, because there's 2 here, plus X should be equal to 0, because the total charge is 0. So what's 2 going to be? What's X minus 2 equals 0? X is 2. Best with anything else other than peroxides and F minus is going to be negative 2. Always remember that. An easier way to remember is just usually, no, all the time, a simple ion is just its charge. That's it. And the charge of O as an ion is negative 2. Just remember it like that. So now they want the oxidation number for N. We already, usually, they're only going to leave one unknown. Everything else you're going to know. So here, if you zoom in, we know that O is negative 2. So we'll keep N's number as X. I'm going to write them down here. And O is negative 2. The total charge is 0. When you add them up, it should be equal to the charge. So when we add the oxidation numbers up, it should be equal to the charge. It should be equal to 0. So that means, look, you have X plus negative 2 times 2 because of the subscript. Negative 2 times 2 equals to 0. It's X minus 4 equals 0. What would X be? X equals 4. And by the way, the oxidation number of O is negative 2, because they're not asking for the oxidation number of O2 or, for example, O4. They're just asking for O by itself is negative 2. That's why we don't put negative 4 here. Okay, next one. So H plus, again, there's 8 rules for these. There's 8 things you have to memorize. These are 2 of them. This one, and this one. H plus, unless with a metal. So if H plus is with a metal, its oxidation number is minus 1. But if it's not with a metal, it's plus 1. And Cl usually is minus 1, except with oxygen. With oxygen, we don't know what it is. So that's what we're trying to find. So let's write everything. We have plus 1, we have X, we have minus 2. So that means X minus 2 plus 1, X minus 2 times 4, X plus 4 into minus 2 plus 1 should equal to 0 because that's the total charge. Add them up, becomes x minus 8 plus 1, which is the same as x minus 7, equals 0. So x is positive 7. Last one. Here, look. Here, this time it has a charge. So look, we already know O is negative 2. And we'll use this as x. So x plus 4 into negative 2 isn't equal to 0. It's equal to negative 1 because that's what the charge is. To negative 1. X equals to 8 minus 1, صح? عشان becomes negative 8 and then you take it to the other side. It's equal to 8 minus 1, which is equal to what? Positive 7. A manganese rod is placed in a 1 molarity manganese nitrate solution. A tin rod is placed in a 1 molarity tin nitrate solution. Two half cells are connected internally by a salt bridge and externally by a voltmeter. Voltmeter reads 1.04 and shows tin is the positive terminal. Manganese is more reactive than tin. Okay. So you have to remember, electrons flow from anode to cathode, and current flows the opposite direction. You can just remember like current, cathode, they both begin with C. I don't know. Remember however you want. So you always need to remember that. And the more reactive one is going to be the anode. So look, in the table I gave with all of the K plus, Na plus, all of that, the more reactive, the higher you go, the more reactive, and the lower you go, the more stable. I mixed it up, sorry. So you want the more reactive one, so you go up for this one. But in the other one, you want the more stable one, so you go down. That's my bad, I mixed it up. In electrochemical, you want the more reactive. In electrolysis, you want the more stable. So here, look, the more reactive one will be the one having oxidation done to it. Will be the anode, because the anode is where the oxidation happens. So you can use two things. Either tin is the positive terminal. The positive terminal is the cathode. You can remember that. Or manganese is more reactive. So that means manganese is the anode. So look, electrons flow from the anode towards the tin. So from the anode to the cathode, and the electric flow and the electric current flows in the opposite direction. The cathode is tin and the anode is manganese. We just said this. Always remember that the current flows opposite to the electrons. Cations move towards the cathode, anions move towards the anode. Remember that. So that means the cations go to the tin and the anions go to the manganese. Give the oxidation half reaction. Oxidized one is at the anode, which is manganese. Remember, oil rig oxidation involves losing. So it starts out solid and it loses 2 electrons. And reduction involves gaining. So it starts out positive and it gains 2 electrons. CuCO3 gives you CuO plus CO2. This isn't a redox reaction because it's just might look like one, but it's not. It's just a carbonate splitting up. That's it. Non-redox. It's just it's a salt. It's a salt preparation based with acid. That's it. This one is, you can calculate it with 2 ways. Either oxidation number, or you just think it gained the oxygen, so it's oxidized. Here, look, if you read the book, zinc, when placed in acid yields, zinc displaces hydrogen from an acidic solution. So it's taking it's giving its electrons to the H plus. And we can also just calculate the oxidation number just to be safe. So look, zinc here, an elemental, anything as an element starts out 0. So zinc here starts out 0. H is +1, so that means Cl is -1, and it makes sense. Now look, so Cl, so that means here H is 0, so we can already tell instantly H used to be +1 and then became 0, so this one got reduced. Already we have reduction, but it has to be redox. So now we check the zinc. The zinc here is 0. We know Cl is -1, and you have Cl2. So look, do 2 times -1 plus X, which we're gonna keep as the zinc, X plus X equals 0. So that means X is equal to +2, صح? Because then it's gonna become -2. X is +2. So that means the zinc went from 0 to +2, and the H went down. So that means one got reduced and one got oxidized. So it's oxidation reduction. An aqueous solution of hydrochloric acid is added to lumps of calcium carbonate. One of the formulas you should memorize for salt preparation is when an acid with a metal carbonate gives you 3 things. It gives you salt, water, and CO2 gas. So since CO2 gas is released, you should expect bubbles. There's nothing here that could give you an explosion because it's just salt and water and gas. Maybe a change in color, still probably not. Formation of a precipitate, no, because Ca with Cl. Remember, halides are with everything except for silver, copper, and lead. This isn't any of them, so you're not gonna get a precipitate. And H goes with anything, so it's still not a precipitate. You're gonna get water, a salt, and the salt here is soluble, so no precipitate. What are the products in the net ionic equation? So a net ionic equation is basically, you have 3 main types of equations. You have the overall non-ionic, means the full equation, no ions, nothing. CO3 gives you CO2 plus H2O plus CaCl2, just add the 2 here to balance. This is the full overall non-ionic reaction. Now they want something called the net ionic. How do you get the net ionic? This is where it comes from. Since some of these are salts and acids can be split up into ions. So look. So that means we can split the 2HCl into 2H plus Cl minus. Anything aqueous can be split up. 2Cl minus. Plus, here we have Ca2 plus CO3, 2 minus. That's everything on the reactants. And now we go, this is the CaCO3. And now we go Ca2 plus still. So this is the CaCl2 plus 2Cl minus gives plus water, it's liquid, plus CO2, which is a gas. That's why they don't split up. So now look, Ca2 plus and Ca2 plus, they cancel out because they're on opposite sides and it's the exact same thing. 2Cl minus cancel out because it's on opposite sides and it's the exact same thing. So this is what's left. This is what they mean by a net ionic equation. After you cancel out everything in common on both sides, what's left? 2H plus CO3 minus, CO3 2 minus, gives you water and carbon dioxide. And they're asking for the products only. So this is the main rule you have to remember about pH. So anything equal to 7 is neutral. neutral. Anything less than 7 is acidic, and anything more than 7 is basic. For example, 8 is basic, 8.5, 8 is basic, 2 is acidic. So look here, A, you have 4 points, A, B, C, and D. First they're asking for A. Which one of these does it fit? Fits this one. It's less than 7, so it's acidic. You choose acidic. B is perfectly at 7. It's neutral. It fits the first one. C is at 9, which is more than 7, so it fits this one, so it's basic. And 12 is more than 7. So D is at 12, which is more than 7. So it fits this one, so it's basic. So now they give you a bunch of oxides and they want you to find out if they're basic, acidic, or neutral. So you have two main rules. Any metal oxide, so I'm just gonna write metal O, and you have non-metal O. O is for oxide. Non-metal O. This one would be basic, and this one would be acidic. There are three exceptions to both of them. So you have something called amphoteric, which can react as both an acid and a base, and you have something called neutral, which doesn't react with either of them, doesn't act as any of them. So for these, it's three metal ones: Al2O3, zinc O, and PbO. These three can act, sorry, it looks like minus. So these three can react as either acid or base depending on what they're reacting with. So if you put them with an acid, they're going to react as a base. If you put them with a base, they're going to react as an acid. The neutral ones, there's three other exceptions: H2O, N2O, and CO. Now the thing is, you can't get confused between N2O and NO2, because NO2 is a non-metal oxide. It's not neutral, so it's acidic. Here, yellow. So this is a metal, so it's basic. This is a non-metal, so it's acidic. Metal, basic. Non-metal, but it's one of the exceptions, so it's neutral. Non-metal, but also one of the exceptions, so it's neutral. Metal, but one of the exceptions, so it's amphoteric. Non-metal, acidic. Metal, it's an exception, amphoteric. Metal, not an exception, basic. What happens when a zinc rod is placed in a copper nitrate solution? The copper, okay. So they're basically just asking which one is more reactive. This is the main point of the question. Which one is more reactive? So you have a cup full of copper nitrate. You put down, let me change the color. You put down a zinc rod. What happens? Which one is more reactive? The zinc. You should memorize it from the thing, or also, yeah, you just memorize it from the thing. Remember, zinc is more reactive. So that means zinc will be oxidized in this equation. So that means zinc loses 2 electrons to become zinc 2 plus 2 E minus. So that means the copper has to be reduced, because where else would these electrons go? So you get Cu2 plus. So remember, there's a bunch of Cu2 plus in the solution. You have Cu2 plus, and NO3 minus, stuff like that. You have a bunch of Cu2 plus. So that Cu2 plus is gonna take the electrons that the zinc released to E minus to become Cu solid. So because the ions here became solid, what happened? They started gaining a lot more mass. So they started depositing on this. They started clinging onto this. You see this? This is the extra mass. the blue color of the solution fades away. Because look, Cu2 plus, when dissolved, it gives a blue color when it's aqueous, but we just made it solid, so there's not enough aqueous to make it as blue, and then the zinc metal dissolves, becoming zinc ions. Yeah, that's exactly what happened here. See, the zinc dissolved and then gave out ions and electrons. How do electrons flow in the outer circuit of a cell? Electrons flow from the negative to the positive terminal of a cell, from the anode to the cathode. Yeah, so you have two circuits. You have the salt bridge, and then you have whatever you have connected outwards. So you're asking for whatever you have connected outwards. So the electrons move opposite to the current. And if you remember from physics, the ideal way the current travels from positive to negative. So it just travels the opposite. Then it goes from the anode to the cathode. Question was it? Okay. In which of the following molecules O has an oxidation number of -1? Sorry, on peroxides it was -1, not +1. So this is what I was talking about as a peroxide. Something 2O2, like that. Like look, for example, Na2O2, H2O2. Here it's 0 because it's an element. Here -2 already makes sense because look, you have -2 plus. Look here. Here you have +1, and you have and it's two of them, so it's 2 plus x equals 0. X should be -2. Peroxide, it's an exception. It's -1. It's an exception. CO2 again. We don't know what C is. But here, look, if it O here, because it's just in a natural like element, so it's gonna be -2. And then again, because the peroxides are exceptions, it comes as -1. And if you check, it's gonna make sense because look, so you have 2 times +1 plus 2 times -1 equals to 0. Does it not make sense? Or even if you don't wanna be sure, you can add 2 times x. Well, what else could it possibly be? 2 plus 2x equals 0. Move 2 to the other side. 2x equals -2. X is 0. Dilute sulfuric acid is added to a mixture that contains magnesium, zinc, copper in a beaker. The beaker is left for about 15 minutes and its contents are filtered. What does the filtrate contain? Okay, so the only reason you don't get copper sulfate, the thing about copper metal, copper and silver, both of them, you have to remember that they both are too weak to react with acids by themselves. In a compound, yeah, like for example CuO can react with an acid, but Cu metal can't. It's too weak. What are the pieces of apparatus needed during preparation of sodium chloride by titration? You don't need a stop clock. You're not trying to measure the time. And you don't need both the dropper and the burette. You don't need the balance. You're not trying to weigh anything. The burette and the beaker are correct. Pipette, you need it. Balance, again, you don't. So it's wrong. Pipette, you need it. These two, you don't need them. This is the only logical answer. Use a pipette to measure the acid and you put it in the beaker, and then you put it in the flask, and then you have a burette dripping into the flask. Which of the following reaction produces a pungent gas that turns red litmus paper blue? You should know that ammonia is a base and it turns red litmus paper blue. So we're looking for whichever one gives you ammonia, NH3. Which one of these would possibly give you NH3? This one. a base plus ammonium salt, ammonium is NH4, base plus an NH4 salt gives you salt, water, and NH3 gas. During preparation of silver iodide AgI by precipitation, what is the correct order? Okay, precipitation, you get two aqueous solutions, two solutions that are dissolved, and you mix them. You stir it with a glass rod like it says, and you filter it, and then you dry the residue. Which of the following produce ammonia gas? C, ammonium salt and base. This one has nothing to do with ammonia. Neither does this one, neither does this one, neither does this one. See again, which of the following reagents can be added to sulfuric acid to prepare copper sulfate? Look here. So Cu is way too weak on its own to react with an acid. So CuO can, CuCO3 can, CuOH2 can, CuNO3 2 can. Anything, when Cu is with something else it can, when it's alone it can't. Which of the following reagents can be added to hydrochloric acid to prepare zinc chloride? Okay, look. Here, now you're going to be confused because like the metal reacted, but this couldn't. Here's why. Metal sulfate, not sulfite. There's a difference between sulfite and sulfate. You have, this is sulfate, SO4 2 minus, and sulfite is SO3 2 minus. Metal sulfates, this one, don't react with acids. They just don't react with acids. So when you mix it with an acid, obviously it's not going to do anything. Which of the following oxides react with only HCl? So which react with an which only react with an acid? Not which do, it's just which only. The basic ones. You have a basic one and an amphoteric one. Now anybody else would like be confused which one do they pick. Here it says reacts only with HCl. That means nothing else. Which of the following oxides react only with NaOH? Again, the word only. The word only. See? And no one or nothing more besides. See the definition at the bottom? So it only reacts with NaOH. It doesn't react with anything else. Obviously the basic one can't react to the base. N2O is neutral. So you have to pick the acidic ones, which are SO2 and CO2. Which of the following react with both? Let's see the definition. Used for the first two of alternatives to emphasize that the statement, it can react with both. Which one? Zinc oxide. Which of the following oxides neither reacts? The neutral one. It just doesn't react, so it's N2O. Okay. They're asking which ones are spontaneous and which ones aren't. Now, let's see. Okay. Spontaneous. See, oh my god. Okay. Cl2 plus 2Br minus gives you 2Cl minus plus Br2. If you remember the whole table I did, Cl was above Br. So that means Br is the one that's going to be oxidized. Because look, we can split up the equation really easily. So we have here, we have this equation. Cl2 plus 2Br minus gives you 2Cl minus plus Br2. You can split it up. 2Br minus, take this and put them on opposite sides. Br2. How do you reach this? You have to lose you have to lose the negative. How do you lose the negative? You lose 2 electrons. It's the opposite for the metals. When you have a metal that's an ion and you want it to be solid, مستحيل put the electrons on the same side so it can gain and become neutral. But here you're trying to lose them, because if you put them here, it's just going to become more negative. Plus 2E minus. And then here, Cl2, it gains. See how it ends up at the end? Plus 2E minus gives you 2Cl minus. You just cancel the electrons, and this is what you get. This is what should happen, because remember the whole list, Cl, just remember this part, Cl was above Br. That means Br is more likely to get what? Oxidized. Br is more likely to get oxidized. Okay, again, Cl was above I, so it's exactly like the other one before it. Cl is above I, so you should expect it to, you should expect Cl to become reduced, which does happen. See, it starts out like this and it loses the two negatives. You expect I2 to be oxidized, which it does because it gains the two negatives. Then here for the last spontaneous one, Br was above the I's. Br, look, this is how it was. Which minus, then you have Cl, Br, I. Least likely, look, okay, least likely to be oxidized. So what does that mean? If this one up here is the least, it means what? This one here is the most. So if you have I with anything, it's always going to be oxidized. So you expect it to be oxidized here. So it loses 2 and it becomes neutral. Now for the non-spontaneous. Spontaneous, if you didn't know, means natural. It just happens by itself. If you look here, for some reason, chloride is the one being oxidized even though it's above Br. That shouldn't happen. So that means what? That it didn't happen naturally. Somebody forced it to happen. Same thing with this one. Cl, if we go back to the list, Cl is above I. But why is Cl the one getting oxidized? Somebody forced it to happen. It didn't happen naturally, so it's not spontaneous. I2 plus 2Br minus. See? Br is the one being oxidized this time. So what does that mean? Someone forced it to happen. Whichever one doesn't look right, whichever one looks wrong, is the one that is non-spontaneous. The given reaction is a redox reaction. Yeah, look, you can check by 2 ways. Either they pass around the electrons or the oxidation number. So again, oxidation number of any element is 0. صح? So the oxidation number of this is 0, and the oxidation number of an ion is its charge. So positive 2. Positive 2. So here it became positive 2. Here it became 0. See? Zinc got oxidized and copper got reduced. This reaction, 2 electrons are transferred. Thus, the number of electrons gained is equal to the number of electrons lost. So, zinc lost 2 electrons to become this. Where did these 2 electrons go? The copper ion took it to become neutral. All cations move towards the cathode, anions move towards the anode. Just memorize that. Circle the sum of all oxidation numbers, and you don't even have to solve for anything. The total oxidation number for a compound is just its charge, and here the charge is 0, so you just pick 0. There's no charge, so that means 0. Sum of all oxidation numbers in a complex ion is equal to the charge of the ion, exactly like I just said from last one. That's why the sum of all of them is 0. Just pick anything. The sum of all oxidation numbers in a complex ion is equal to a charge. Choose a reason to explain why excess magnesium oxide is used in step 2. Here in step 2 it said continue adding magnesium oxide until it... This is preparation of magnesium nitrate crystals. You're trying to get crystals. So you want to neutralize all the acid. You don't want any acid left. You want the metal to be in excess. You want a huge dry lump of the metal at the bottom of the... You want it to be a residue. So you use it to neutralize all the acid. And then in step 3, you filter it with the funnel paper, all that stuff. A solution which no more solid or solute can dissolve at that temperature is called saturated solution. Always remember at that temperature. It came in the written part today for the periodic. If you didn't write at that temperature, you lost a mark. You lost half a mark. So saturated basically means if you add any more of the solid, let's say I have a cup of salt water and I say it's saturated. That means if I add any more salt and I keep mixing, no matter how much I mix, at that same temperature, it's not gonna dissolve. It's just gonna, those salt flakes are just gonna go, just gonna sink to the bottom. A cold glass rod is dipped from time to time in the solution to check the formation of salt crystals at the tip. This shows that the solution is saturated. So I said at that temperature. So that means if I stick, again, let's say I have the same salt water thing and I add a bunch of ice. It's not gonna dissolve. A bunch of salt, sorry, it's not gonna dissolve. If I put a block of ice, the solubility is gonna go down because the temperature also did. The temperature and the solubility are directly proportional. So when one goes down, so does the other. That means when the solubility goes down, it's gonna, I don't know how to explain the exact way, but it's basically like undissolved, like re-solidify. The salt that was already dissolved, because it got colder, is gonna become solid again and it's gonna go to the bottom. Another experiment, dry the crystals by heating. What does this result? The remaining water will be lost too quickly, which will lead to the breakdown, the crystals becoming powder. Just remember this one. This one just doesn't even make sense. And this one maybe, but just remember this one. During the titration of an acid, the base color change when phenolphthalein is used. So look, anything that ends in phthalene is colorless in acid. Just remember that. Anything that ends with phthalene is colorless in an acid. Then you can remember it's pink by, P, and this one starts with a P and this one starts with a P, like that. So if the burette was filled with dilute hydrochloric acid and the solution was slowly added to a conical flask containing dilute sodium hydroxide, what will the color change in the conical flask show? Okay, so you have a burette. So this time they're flipped. Instead of the base being in the burette and the acid being in the beaker, they flip them. So you have an acid in the burette and the base in the beaker. So that means when you add the indicator to the beaker, it's gonna start out with its basic colors, not with its acidic. So litmus is blue in basic. Methyl orange is yellow in basic. And again, phthalene, see it's colorless in acid, but that's not important. Phthalene is blue in basic. Just remember. I'll try to draw a table really fast explaining all of them. So look, you have 4 main indicators that we learned. So we're gonna go like this. We're gonna go like this. Acid, base. Let me make the space a bit more. And then base. So look, you have thymolphthalene. Yeah, I'm gonna make lines for all of them. And then I'm just gonna circle them because there's not enough space to write. So the first one is litmus. Second one is methyl orange. Third one is thymolphthalene. And the fourth one is phenolphthalein. So I'm just gonna write phenol. So in an acid, both of the phthalenes are colors. The litmus is blue. The litmus is red, sorry. And so is the methyl orange. So I don't know if you saw. The only 2 possible things you have for acid is either red or colorless. And just remember the phthalenes are colorless. You'll never get an acid question wrong, like the indicator, what color will it be? You'll never get it wrong if you just remember that. It's either going to be red or colorless. And if it's a phthalene, see, I'm just going to write it. If it's a phthalene, it's colorless. Now, phenolphthalein in a base is pink. Thymolphthalene in a base is blue. Methyl orange in a base is yellow. and litmus is blue. So look here, another way you can remember for methyl orange what it's gonna be. You already know in an acid it's red already. Don't even have to remember, just remember phthalene is colorless and that's it. So that means the methyl orange is gonna be red in an acid, and it's gonna be a base in yellow. So what do red and yellow make together? Orange. So I remember. Litmus, it's, you just remember it, but it's also kind of like common sense. You know the pH meter where all the way to the left is red and all the way to the right is blue? It's basically just a way more simplified version of it. And then for these two, just find a way to memorize. You know, you could just use the, or like this one starts with P, so there's this one, so it's pink. So that means it just leaves the other one to be blue. So that's why they change like that. Strong acid with a strong base to produce salt and water is neutralization. You're neutralizing both of them. You're just making them completely neutral. That's why it's called neutralizing. So if you have, let's say, 3 pH and 10 pH, if you have 3 pH and 11 pH, they're both 4 above, you just combine them and they become, they neutralize each other. By the way, that's an example. It's never like exactly like 4 less and 4 above. It's just an example. Again, oxidation number, it's easy. So O, remember it's always going to be -2 unless with F or with peroxide. Is this a peroxide? Do you see Na2O2? No. Do you see F? No. So O is -2. Here they want the one for N. So we know that H is +1. So we have H, N. I'm going to write them all separately. This one is +1. This one is X. This one is -2. The total charge of the whole thing is 0. Add them up. And also it's times 3. So it's 1 plus X minus 6, because -2 times 3 equals 0. X minus 5 equals 0, because +1 and -6. So X is 5. Now here, we already know O already is -2. So we have, again, I'm gonna separate them. So you know this one's -2, this one's X, and the total is -1, yeah? This is the total. So you have X minus -2 times 3, 6, equals to -1. Take this one to the other side. X equals 6 minus 1, supposed to 5. And then for the last one, anything in its elemental state, so H2, O2, NH, Na metal, is gonna be 0, because it's just an element. So here you have to find out which one should be oxidized and which one should be reduced. You see here they're both undergoing oxidization. That's wrong. One of them should be reduced. And how do you tell? The E is basically the potential for it to be oxidized, depending on the reaction. So for example, if they gave you both of them flipped, then that would be the potential for them to be reduced. But here, look, in the oxidation, you can tell, in this reaction, you can tell it's oxidation. Why? Because it's releasing electrons, it's losing them. So which one has a higher potential? Zinc, obviously. So that means what? You have to flip this one, because this is the oxidation potential, and the -0.8 is the oxidation, is the E0 of the oxidation. You want the one of the reduction, because one of them has to be oxidized, the other has to be reduced. So you flip it, it becomes positive,